Discussion topic on the way the artificial intelligence evolves and a bit of what we were to expect from in the nearest future. Humans have more or less figured out how to deal with the hard manual labor. Gadgets and appliances have appeared. Gradually, we are getting rid of normal physical work. The price to pay for this is sedentary lifestyle, the absence of physical workload, and hence a bunch of health issues. Now the world is trying to abandon intensive intellectual work. Actually, not so much intense and that which requires simple thinking. They say that even the latter should be ditched. Up till now it has been possible to get rid of the monotonous and therefore exhausting, moderately challenging mental activity. That will help to machines and gadgets too. However, there's a temptation to go further and liberate the mankind from any mental activity whatsoever. It's better not to reflect on what we'd have sacrificed in this case. The cynic man wants to get rid of her completely and dedicate himself to various games and pleasures. Therefore is such a strong interest in artificial intelligence systems, which actually originated from the desire to play chess with the computer. While getting excited about the idea, talented humans created quite a lot of useful things, which nowadays is interpreted as a breakthrough and a path to progress. Though perhaps it's not a breakthrough but rather the breakaway. They have to figure out how the human brain thinks, how one out the thing to principle and how to teach the machine to do the same. Indeed, how does the human brain get to know the world? The key element of the cerebral cortex is the neurons, which all cells which a paradoxical reaction to irradiation. Weak irradiation makes them enraged, whereas strong irradiation leaves them almost indifferent. A strong response of one neuron subdues its neighbors. It is interesting that the human brain is a paradoxical in the same degree. Powerful noise doesn't prevent you from falling asleep, whereas a voice said in a whisper while you sleep would make you wake up in fright. The extreme shock is able to immobilize human and other brains, suppressing their desire and ability to escape. The cerebral cortex is a multi-story building where the top looks like a service floor, a huge bunch of cables, each of which connect neurons to one another. Any external disturbance that sounds to the brain via these cables causes alarm among neurons. This alarm can be increased or reduced additionally by chemical components injected into the blood. Hence, image centers of excitation recognize it as a reflection of various patterns, where these patterns partially coincide with even 60–70% of the patterns previously stored and dormant in the memory. The recognition occurs. The mechanism of motor reaction goes off. It is no wonder that people want to create some artificial mechanism acting in a similar way. The idea of the device with the ability to recognize the input images is the idea of perceptron, neurocomputer and neural network. It all started with Frank Rosenblatt's perceptron Mach 1, which recognized with some errors the letters of the alphabet in early 1960s. As usual for science, 10 years later, Martin Leminsky, who had been a schoolmate of Rosenblatt, strongly criticized the capacities of the perceptron, which led to delay in the development of the neurocomputers in the following decades. But later people still decided to use the perceptron as intended, because nothing else had occurred to them. The neural network is a web composed of neurons which we have to teach. It is necessary to give it several taxes solutions and adjust network settings so that the network would be able to generate these solutions independently. Though there are the networks that do not require training, but there's a lot of problem with the trained network too. If the tests show that the number of errors decrease after training, They mean we got luckily the training is successful. But when the number overall grows, the network just remember all that it was told during the training and really learned nothing. The politically correct term of it is overtraining. Then the network is considered as untutorable and should be rejected. At further, mankind decided to take away the ability of higher powers to predict future, realizing that each sequence of operations and actions can be interpreted as a computation. And then he wanted to create something in his own likeness. The fact is, the early success of developers of the artificial intelligence have lowered the demand to its level. Nowadays, the main future of the artificial intelligence is considered to be the ability to find solutions independently. Hence, the natural intelligence has become an important but only a special case of the intellect in general. Each set of the interaction agents have the ability to perceive and respond to the environment change may be regarded as the intelligent system. The results of this interaction can be considered as a solution of the problem or even realization of some action. There is another reason why the network is as powerful as capable of providing its own solution which the experimentalists did not expect. The network violates the view of the world in this case. Such clearness is discouraged and this excessively smart network is objected to. The rational response on this situation is to increase the quantity in quality of training tasks to pick the stability of the worldview. The hypothesis of necessary development expanding intelligent system requires as great amount of the basic knowledge to prevent the destruction of the current worldview. Human being demonstrate the same thing if the student after studies answer perfectly well, looking honestly in your eyes, but can solve any problem on the subject, then the experienced teacher knows that the person in front of him is untutorable. But sometimes the examiners make a mistake and take such students for untutorable if he suggests other continuations and variants hidden from the examiner. The examiner may be a prisoner of the stereotypes imposed by the training programs or simply might not be adequately equipped to deal with the discussions about new approaches to possible solutions of the problem. But now even the highly advanced neural networks cannot match the human intelligence in the slightest degree. In addition, Marilyn Minsky was right in some way because the neurocomputer with the insufficient number of neurons is not capable of solving a specific class of problem. This is a lower limit, but there is an upper limit. An excessively extended neural network can produce undesirable results. Such a computer will revise results all the time, get snarled in its output and will turn out to be completely useless, the loss of the solution uniqueness. The same can be observed on human beings. The intellectual who is instructed to solve a simple problem will torment the problem originators with doubts and arguments, so simple tasks should be entrusted to the man of action, not burdened with an extensive education and intellectual abilities. All investigators have been aware of the difficulty to understand how neural web produce knowledge. But as always, people need a result. Only enthusiastic mathematicians wish to go deeply into the needle's details. Indeed, customers need a device that can do something useful, but they are too busy to investigate how it works. It is sufficient for them to obtain the user's manual. Enthusiastic people who are not aware of what is happening in this black box neurocomputer have made a lot of such devices, but using the methods of selection and sorting. These neural networks learned what their stubborn creators required, but for the rest neither the first nor the second were fit. Such in the apotheosis of empiricism. So, Alan Newell, after late fascination with chess, has created a program 1954 based on the methods of Claude Shannon, which produced a long line of followers. However, the mathematical logic which had been developed long by efforts of Frederick Frege and his contemporaries was not put into practice, which is not surprising. Games seem to be more interesting. However, a method suitable for solving the problem of creating chess programs without the use of correct mathematical formalism was proposed by a real inventor, Alan Turing. Turing. The efforts by the Rand Corporation, employees John Shaw and Herbert Simon, supported by de Groot and his colleagues, result in the development of the IPL language 1956. The predecessors of the Lisp computer programming language, which was created by John McCartney in 1960. Incidentally, Lisp processing language, is based on a system of lambda calculus formulated for the first time by Alonzo Church. The use of formal mathematical logic to correspond and execute computer programs proposed by John Allen Robinson in 1965 proved to be revolutionary. Based on this method, albeit with a number of differences, Alan Komrower developed in 1971 the Prolog language, which used the first-order predicate logic. By the way, the resolution method was applied earlier by young mathematician Chuck Ebran. Thus, in the early 70s, the programming languages for artificial intelligence had been create, Lisp, Prolog, Planner, Reduce, oriented towards various tasks. Using the artificial intelligence programming languages based on mathematics, one can review the entire solution of the task and correct it if necessary. Such systems are referred to as expert systems. Of course, this is different from the neural system where one cannot understand what is going on inside the black box neural computer. At the time, the logic programming expert system possessed one essential shortage: they operate with only two logic values, true and false. Sadly, that's just not the way life works. It was necessary to go the structure of fuzzy concepts. Therefore, the theory of fuzzy sets and fuzzy logic, proposed to the mankind by Lord Faraday in 1965, turns out to be very useful. In 1993, Bart Kosko proved the important theorem that any mathematical system can be approximated by fuzzy logic. The integration of fuzzy logic concepts formulated by mathematicians with artificial neural networks was initially performed by Yang from the Taiwan University. This allowed us to understand what is happening within the neural networks while solving tasks. Thus, a historic unification of artificial neural networks and decision-making expert system based on the logic has happened. The human being filled their database and knowledge base during all their life. However, when we want to create an artificial intelligence system and going to fill data and knowledge bases, that's when the problems arise. At first, the human being processes a set of knowledges that he believes to be known by default. All this knowledge should be spoon-fed, explained to the artificial intelligence system. Next, database should be filled by experts and their job should be highly paid for. Third, the time necessary for database filling, checking and rechecking is rather considerable. All this is disappointing. So, in what way artificial intelligence can be helpful for us? Neural networks catch because of poor performance of car engines. Neurocomputer look for similarity in a variety of objects, which is also necessary. Expert system make warning to the military pilots and give some recommendations how they would make right. Such system assist pilots, train and ship drivers, but the final decision is usually up to a human. However, why wouldn't we let cars drive without a driver on some roads? So can we hope for a development of the artificial intelligence, the abilities of which will be comparable to those of the human brain. The apparent inconsistency between the reaction rates of natural neuron and artificial neural network is very impressive. The rate of human decision-making over the far exceeds the rate of the final generation of result by the modern artificial neural networks and expert system, especially for multitask mode processing. What's the matter? The matter is likely that the human brain, its mega processor, simultaneous processing by this huge number of the processor accelerates the design making tremendously. Therefore, in my opinion, all the efforts of the researchers should be focused on the development of mega-processor systems of new generation. The supercomputer Chan 2, located in National Supercomputer Center in Changzhou, demonstrated performance of 33.86 petaflops, almost 34 quadrillion thousand trillion floating points operation per second. In Britain, the Gray XC40TM. The best achievements of IBM is the neural synaptic processor True North, 16 million digital neurons and 4 billion synapses, but it is not enough. To develop the artificial intelligence system is necessary to provide its connection to the outside world and the ability to self-learn. For example, as the IBM company is doing IBM is to develop the artificial intelligence system is necessary to provide its connection to the outside world and the ability to self-learn. For example, as the IBM company is doing, IBM is developing the interactive artificial intelligence system based on the Watson supercomputer that has access to the technologies of the cloud system Watson Developer Cloud. Intuitively, developers, while examining the intelligence system, have realized the benefits of the network structure each element which has: first, independent access to external data and general information; second, internal memory in addition to libraries; third, sufficient autonomy. Basics, they tend to use this synergy. As an example, consider the network structure of Lloyd's Insurance Smart and integration of Teams in the computer firms. Thank you for your attention.